Hi, welcome to It's a Trap, How Our Abstractions Are Failing Us. My name is André Henry. I'm currently an engineering manager at Venmo. That's my wife Nivea and my cat Zuko. I've been in tech for over 20 years. I've held lots of positions like lasers, code, math, and science. You can find me on Twitter at 7GROK, 7grok. Why are we here? We're here to talk about the trade-offs in the abstractions we use so that our engineering customers can be more productive, less frustrated, and more open to change. So let's get started. What is an abstraction? On the screen, you see a definition of an abstraction, of the word abstraction I took from Wikipedia. I like this definition because it specifically calls out a technique for arranging the complexity of computer systems. That's very appropriate for the SRE domain, and it kind of bridges the gap between us, our domain, and the software engineering domain, right? And if you're wondering, that's a computer in the picture on my right. So there's a fundamental theorem of software engineering put out by or attributed to David J. Wheeler, right? And it goes, we can solve any problem by introducing an extra layer of indirection, and some people add a humorous bit to it that says, except for the problem of too many layers of indirection. And I think we need a similar fundamental theorem of infrastructure engineering where we replace indirection with abstraction, right? We feel we can solve any problem by introducing an extra layer of abstraction. So how does this all go together, right? Let's do a quick review and start by taking a step back, right? Here you have a replica vintage PDP-11 computer, basic abstraction of an operating system, not 100% fully abstracted from the end user. You still have to use the front panel switches to set load addresses on the system, right? That was then. Now we have full servers, full operating systems, complete hardware abstraction layers, providing almost unlimited and universal portability between various systems. We also have hypervisors that abstract away the specifics of any hardware system, allowing multiple operating systems to share one piece of hardware like it's the only customer on that piece of hardware. And then, how did we manage these systems, right? Mostly through manual systems administration, right? Couple servers at your local ISP, not a big deal for one or two people to manage. But that era didn't last very long, right? Sure, there are some places right now that have manual systems administration, but if you're dealing with large cloud infrastructure systems, we have adopted configuration management tools, right? These tools are great, and they abstracted over the configuration of the various systems, and they allowed us to scale our handling of these systems so that one or two people, instead of now only handling tens of systems, can handle hundreds or even thousands of systems, right? And then we also have virtualization, right? Brought about the cloud era, really massive scale for some of us. And this is kind of where that whole abstraction on top of abstraction really started, right? First, we layered on the virtualization layer, then we layered on the hypervisor, then we layered on multiple operating system, right? So when you think about the virtualization and the hypervisors, this is where we really start to lose touch with some of the hardware, right? We really understand that there's something underneath it, but depending on your job, your function, your experience, you might not have any exposure to the physical hardware that runs these virtualization platforms. Now, some of us early on realized that this could be a problem because you've had to deal with noisy neighbors, start to deal with capacity problems, and just general debugging of applications that don't perform so well in these early virtualization environments. And then the next kind of evolution we had was kind of infrastructure as code, right? And it's kind of the thing that wrapped everything that came before it: manual systems administration, virtualization, cloud scale infrastructure. It's really the thing that let us scale to levels that have been unprecedented in times past, right? We have standard configurations that are version controlled, repeatable, testable, and it took scaling to the next level, right? These new tools really lowered the barrier to entry, and you no longer really need a large team to scale to large infrastructure. Combined with virtualization, these tools unleash lots of new capabilities and some of the most popular internet applications that we're all familiar with, right? So far, so good. So, should we have stopped here, right? We have massive scale. We've enabled the hyperscalers. We have standardized configuration management. We no longer need teams of thousands of people to manage machines. We can treat systems as cattle and not pets. And, as stated before, we have, grown our infrastructure to massive scale previously unheard of. So why didn't we stop there, right? We have cloud, infrastructure service, elastic scalability, well-defined configuration, and we've said the hyperscalers, right? But there was still something missing that we wanted to get, right? There was more capabilities in this hardware that we want to unlock. So when you look at what was missing, right, it's not even necessarily that something was missing, as just new ways of designing and deploying software required different types of tooling to handle these changes with software architecture. One big driver for this new way of working was microservices and large distributed systems. So where did we go, right? We kind of evolved from individual virtual machines and individual servers to manage with the config management system. We evolved into containers and container orchestration systems, right? Containers brought about some kind of standard packaging, kind of whole system dependency management, and Kubernetes and Docker Compose and other things like that brought container orchestration to the masses, right? It kind of evolved systems that we had in the past, homegrown systems that were based on Mesos and the like, right? So what did we gain, right? The prior generation of tools manage workload deployment to servers or groups of servers, right? They didn't really look at optimizing utilization, and they were very much focused on the configuration domain, right? We treated configuration as a separate domain, separate from the software domain. We had a separate workforce that handled configuration of server infrastructure. We have a separate workforce that handled network configuration. We had a separate security workforce, right? And these new tools kind of combined all those things together and really brought them all under one umbrella. But the question we have to ask ourselves is, what's the benefit, right? Who benefits and what are the gains, right? Did the business benefit? Did engineers benefit? Did consumers benefit? And who did we do this for, right? Like, from experience, we know that not all developers are able to fully grasp some of these more complicated abstractions we put. And it might not necessarily be for lack of trying or lack of wanting to. It's not their core domain. It might not even be important to them. And especially when, things change so fast, there might be something new coming out in 5 years. What's the benefit to them of going all in on this new way of doing things, right? And the question we have to ask ourselves is, did we do something wrong? Did we not position it the right way? And why don't they see the value in this, right? And we also have to recognize that learning is time consuming, right? And it's not an invalid concern when the way we manage infrastructure may last 5 years, may last 10 years, which is only a small time span in anyone's career. So the question now is, did we take it too far? Was there a place we should have stopped and maybe refined what we had versus an all-out evolution of this? So, are we all relaxing in the sun and baking bread? Well, maybe the baking bread bit, thanks COVID. But we really have to ask ourselves, that all these new abstractions make our jobs easier as SREs, right? We went from a one-to-one relationship between software and hardware to a multi-layered configuration and deployment where we have our business software, lots of stuff, and then we have a layer of lots of other stuff, and then maybe we have the hardware layer finally, or maybe we have another layer before you get finally down to where the code meets the metal. And, when we really look at it, it's almost like we're now all Starship Captains, right? We have become managers of ecosystems of complexity, right? If there is a problem with the application, we now have to start peeling back all these layers to figure out what's causing the problem, right? Is the abstraction broken? Is the layer it's abstracting broken? Is the other layer broken, right? And, what's all the way down, right? Is it turtles all the way down? Because the individual software engineer might not understand all the layers that are covered up by the abstractions that we use. And then we have to ask ourselves, how much of it do we all need, right? This is an actual diagram from the Cloud Native Computing Foundation of their ecosystem, right? Now, I'm sure this is a little bit exaggerated with every vendor listed and every kind of systems management, orchestration management, logging, networking software involved. But when you look at this, it's a little bit daunting even for us. And then imagine what this feels like when you are a software engineer who's used to writing your code, packaging your code, and deploying your code. And then now you have all these systems in between you and the thing you ultimately want to do, which is deploy your code, get it out to your customer, and profit. So I think we need some balance, right? And by that, I don't mean that what we have is bad. I don't mean that it's 100% perfect. And what I want to call out is that it's good for some people, not so good for others, and could use work before others get introduced to it. So what's going wrong, right? Obviously, it's not all sunshine and roses. If not, I wouldn't be here talking to you, and chances are we all wouldn't be here at SREcon. So, we forgot about our customer. And by customer, I mean the consumer of your abstraction, right? It's very important that our users understand what we're abstracting, right? Don't just say we abstract it all the way. You have to explain the limits of your system, right? These limits are your reliability, right? The things that your abstraction doesn't cover, the things the user does not know, those are where you can fail if your end customer is not properly educated, right? And especially in the time of COVID, as we're all going remote, as we're trying to onboard new engineers, new coworkers, it's very important that this becomes, normalized, right? We have to explain the limits of our system, and the more complicated these systems are, is the more difficult remote operation and onboarding new employees become. And we also have to remember that it's not just APIs and YAML, right? We also require and need a significant amount of documentation to cover all these abstractions. And you might think to yourself, well, I wrote this abstraction, you just drop 2 lines of code in and it does all this magic. Yes, that's good. So you might not think that you need to document the abstraction, but what you need to document is what the abstraction does, right? When you have an abstraction to automatically expose a service, right? Does your user know that, for example, it might not provide authentication and that it's their bits, right? When you have an abstraction to deploy an application, does the user know that it can only scale up to 20, 200, or 2,000 servers, right? Your wrapper doesn't really eliminate the need for that documentation. It changes the type of documentation you have to write, but it does not eliminate the need for it, right? You also have to remember that eventually you and your team will move on, and your abstraction simply becomes someone else's broken code, right? We've all been in, or most of us have been in a situation where, wow, I wish I could extend a system this way, but I can't because the whole system is based on this library or this abstraction or this other thing, and it has these limits which are now preventing us. Maybe it's not a physical hardware limitation or a scalability limitation. Maybe it just doesn't support the new ways that your business wants to operate, right? So then you have to ask yourself, how will your abstraction evolve and grow with your business needs, right? Does it have a formal plan, or is it just ad hoc? I would argue that your abstraction needs a plan. It needs to be tied to the way your business operates, and it needs to be deliberately evolved and managed to keep up with the business. And, we've talked about this before, but there is a real computer somewhere, right? And as the old saying goes, well, old in cloud terms, there is no cloud. It's just someone else's computer. For the life of me, I couldn't find the origins of this. If anybody knows, please reach out on Twitter. When you dig all the way down, you realize that there is a computer, right? And another layer of abstraction will not eliminate the physical limits of this computer. Out of sight doesn't mean out of mind. Out of sight simply means that's where it's gonna fail. And you might think, well, your end user is gonna think, well, I configured it, why doesn't it work? Well, how did you configure it? Every system has limits. Every configuration runs on real hardware. All configurations have trade-offs. It could be scalability, it could be performance, it could be cost, right? You might make it easy for a user to massively scale their app. Okay, great. Did you put a limit there? And when they scale your app up to 3,000 nodes and it takes a couple of days before anybody to notice, you've now blown your infrastructure budget for the quarter. And the other thing that this results in is that we're now all presiding over silos of knowledge. And I know we think that wasn't necessarily the goal of all of this, right? We wanted to have distributed knowledge. We want everybody to have access to it. We wanted to democratize infrastructure knowledge. But once again, we have to realize that infrastructure knowledge is very specific. It's taken most of us years to gain that knowledge. And a software engineer may or may not care about that knowledge, right? Because they also have their own domain they have to be comfortable with, right? So because of these silos of knowledge, we end up leading users and, being extremely involved in what they're doing versus them being guided by the documentations and the system we've implemented, right? And you might be like, well, no, I don't have silos of knowledge. But I encourage you to look around and look at how your infrastructure teams operate. Look at the various infrastructure team domains you have, right? You might have an observability team, or you might have a logging team, or you might have a security and authentication team, right? Those silos of knowledge are there. They never went anywhere, right? So we really have to understand what is the value of the abstraction that might be wrapping these domains, right? If your abstraction is clean, if it's well documented, then you probably shouldn't need teams that deal with these types of subdomains. So the other problem you run into with these abstractions is that they can be difficult to debug, right? When something is not working, what is the cause, right? If we know that there are limits to everything, if your abstraction doesn't properly encode the limits of the system, this can really make problems difficult to debug. Is it the abstraction that's broken? Is it the underlying system that's broken, right? Or you may have interesting behavior, emergent behavior, right? I'm not saying that your system is going to become sentient like Skynet, but I feel like, emergent behavior in these types of complicated systems is something we need to analyze more, right? I think that too many of the problems that we debug on a day-to-day basis are not specifically related to the business logic and the business code that we write, right? They stem from the interaction of that code with the underlying infrastructure and systems abstractions that we deploy. And one has to ask the question, if we strip all the abstractions away and we go back down to a very base level, right? How many of these tools would we need, and how many of these problems would still exist? And also, what is the true cost of some of these abstractions, right? Some of our systems cost more than the value they provide, right? How many extra compute do you need to manage your abstraction? How many extra people or team members do you need to staff up the various subdomains and knowledge silos it takes to operate your abstraction, right? And this is not strictly a build versus buy, right? I know a lot of us look at our abstractions and they're like, yeah, we don't have ops staff because, for whatever reason. But are you sure you don't have ops staff, right? Some of your job descriptions, some of your setups kind of look like a knock, right? Looks like ops. So we really have to analyze this with, a fairly critical mind and really understand if you're getting the benefit that you expected, right? And we also have to think about the time versus the value versus how many times you're going to need to use this abstraction versus money, right? So not everything has to be abstracted away if, all those dimensions don't meet appropriate thresholds for this. And you might be asking, well, what are these thresholds, right? I think it's difficult for me to say what they are for any one organization, right? Because they vary and the cost of them is different for everybody. But what we can talk about now is, now that we have all these things to consider, where do we go, right? What can we do? And I think it's important to realize that we're not alone, or at least I'm not alone with these thoughts, right? Other technical groups have had to come to terms with some of these, right? The automation folks are thinking, wow, everything is automated away. Nobody knows how to operate the systems without the automation, right? How many of you have been in the position of trying to figure out what happens when Slack goes away, right? We're all automated now with chatbots. Yay, chatbots. But when Slack's broken, how many of you find yourself searching through pages of documentation just to kind of figure out how to do a manual deploy, right? And now that we're all remote, it adds another layer of complexity because you just can't reach over to the person next to you and ask them, hey, quickly, how do I do this, right? If that documentation isn't in place, it's making your remote working very, very challenging, right? And software engineers have also had to come to terms with this, right? They've thought about dry. They've come up with YAGNI. Dry means don't repeat yourself. YAGNI means you ain't gonna need it, right? 10 years ago, software engineers were all about interfaces and interface abstractions and making interfaces for everything in certain communities. And then they realize they just end up with tons of interfaces that were only ever used once, or some even not at all, as the systems evolved, right? And they've had to come to terms with, well, why should I make an interface for something I'm only gonna ever have one of, right? And I know our domains don't exactly map one-to-one, but at least it gives us like a common community that we can reach out to and talk to and exchange ideas with, right? And this community, they are our customers, right? So talk to your developers, talk to your engineers, and ask them how did they draw the line between implementing interfaces and deciding when not to do it, right? I know that some software engineers are like, well, if I don't need a thing more than 3 times, then I'm just gonna repeat it. So as I said, we have communities in common. We just have to reach out and we gotta talk to them. One thing that we really have to talk about is, are we solving problems with our abstraction because they're problems in another tool, right? Dependency management is a good one to look at. Is the container so popular because it solves the lack of dependency management or makes it easier in certain tools, right? And if your abstraction is compensating for a problem in another tool, should you write an abstraction to solve that? Or should you solve it in the other tool, right? Can you use other packaging schemes like Uberjars or Porter or any of the other app packaging tools out there, right? I was once in a project where I was developing a Scala app. And when it was time to deploy, it was kind of challenging to figure out what we're going to do with dependency management. And lots of ideas were thrown around. And, out of the blue, I said, why don't we just package all the dependencies into the jar? And everybody just looked at me and I'm like, it's not going to be that big considering some of the other things we push to the production infrastructure. And we can generate it from our existing build system without adding much more configuration. And you will never have to worry about the problem of not having the right dependency. And everybody was like, oh, that works. And I know that there are other languages out there that support the concept of, all-in-one deployables. Static linking has its trade-offs. So, we should definitely consider the problem we're solving and where it comes from. And, another thing that you might want to consider, another example is, fast provisioning. You're like, oh, I need to scale really, really fast. Do you really need to scale really, really fast? Right? Would a pre-baked image work? If your business operates on a well-known schedule, you can pre-scale. You can scale up on a schedule and scale down on a schedule, right? I worked for an edtech company in the past, and our schedule followed the school day. When students came on board at 7 a.m., we needed a ton of capacity. And by 3, 4 in the afternoon, we needed to deprovision that capacity. And the quickest way, and this not necessarily the quickest way, but the simple thing for us to do was to pre-scale. We used a schedule, we turned on a whole bunch of compute, and then throughout the day, we ramped them down. Lots of tools have the capability to do that already. Something as simple as an auto-scaling group supports a time-based scheduling, and that's exactly what we did. And for a little added complexity, we gained, the elastic scaling of more complicated systems. And also on that project, we used an ecosystem-specific tool for dependency management, right? We researched what our options were, and we picked a tool that just managed our dependencies, and we took the time to modify our build system so that dependencies were properly managed and versioned. Right? So the question you have to ask yourself, right? Did you add value? And value is kind of a large or loaded word, right? But think about it from this sense. Are you doing the right thing? Are you enabling the business, enabling your customers, enabling engineers to deliver business value, be more productive, but with minimal added overhead and minimal added mental load, right? Think about the goal of the problem you're solving, right? What are you trying to accomplish? And is this the most efficient way and sustainable way of doing it, right? Because remember, as I stated before, all abstractions are going to have a life. They have to be managed, right? They need to have a lifetime and a life cycle that's managed not only with the application, but with the business, right? A great example of this is microservices came into style, Kubernetes came into style. Microservices are kind of not fading away. They're not as popular in certain circles as they were before. People are now looking at, micro monoliths or many monoliths floating around. For those of us that are going backwards, maybe it's you, or maybe another engineering community that's doing this. Are they reconsidering their investment in Kubernetes if they did invest in Kubernetes, right? With micro monoliths, what's the benefit of bin packing now are you going to get, right? If it's a large resource consumer, what benefits bin packing going to give you? Unless you need the rapid scalability of a containerized solution and Kubernetes management, can you use something with less complexity, less resource overhead to achieve the same goals? So, right, I put this here, even though we all know it, right? But I want to call out, what is our job, right? I want to point out that we should keep in touch with our origins, right? If SRE is incorporating aspects of software engineering and applying them to infrastructure and operations problems, we should look at what the software engineers are doing, right? As they evolve their understanding of abstractions and systems design, we should also evolve our understanding of those things, right? And as it says, our goal to create scalable, reliable systems, right? They have to be maintainable as well. And remember, creating a scalable and reliable system is not only about the technical parts, right? we also have to consider the life cycle of the things that we implement to do that. How do these things grow? How are they managed? And how does the business evolve with them? So, what guidance can I give you for thing.next, right? Like all things in tech, there's no one size fits all. Consider the root of the problem you're attempting to solve. And is this the best way and the best place to solve it? What are the downstream impacts and the future impacts of your solution, right? One thing that can guide you is think about your customer, think about your service level objectives and your service level agreements, right? How can you meet them with minimal overhead and minimal complexity, right? You don't always have to pick the abstraction that's the easiest thing that you can think of that you know will do it, right? If possible, challenge your business on these metrics, right? Challenge yourself, challenge your engineers. Think about the trade-offs that you're going to make. Think about the life cycle of your planned solution. And remember, it's more than just build versus buy. It's more than just, the simplicity of the thing from one dimension, right? There are many dimensions when you analyze a project. And, don't be afraid to roll it back. Think about the sunk cost fallacy, right? Not because you have this large investment in some abstraction or some particular ecosystem means that it's too late to undo it, right? If you can justify the value in undoing it, you should, right? If it'll make everybody's life better, have a better day, think about undoing it, or think about not doing it to begin with. Thank you very much. You can find me on Twitter at 7grok, and I'll be on Slack for questions.